Okay, I found the cord. All should be well now. So, as you'll notice, we have two power inputs here. The reason for that is just logistics, because this is the modern ATX power supply. And this is the empty box that I've used to consolidate all these other wires, including the 110 volts for this transformer, and this transformer, these three laptop power supplies. And I think I have some other stuff in there, but that certainly helped manage all of the wires and neaten this up, and so it doesn't look nearly as scary. All right, and so I even made a cable so that there's neaten these up so that the two are joined together as one, so to speak, so that kept it nice and neat. So here's what I'm going to do. This is plugged into the backplane, and I'm just going to energize this thing. Right now I have, as you can see, there's a switch here for this power supply, but I don't have a switch for these, right? These are either they're plugged in and they're working, or they're not. And so right now, the way I'm going to turn it on is just plug it in. I guess I'll go for a different switching system some other way. Probably end up putting a switch on this cord eventually if this all works out well. But, you know, this is a first test, so the way you turn it off is you unplug it. So here we go. First time energizing this with the backplane engaged here, with it plugged into the backplane. So I'm not expecting anything because there's no boards in the backplane. There's no front console, front face, front console, front control panel plugged in. So here we go. See if we see any sparks. All right, no sparks, no magic smoke, so this is good. Small steps. All right, so we have power here. We should have power across all these things, and so let's run some tests. So now we're just going to rotate this thing over, and what I want to do is I want to test directly on the backplane. So here we go, just tipping it over here. There we go. And here's our backplane. So, volts DC. Here's our meter. That looks pretty good. We can read that, no glare. And let's test some voltages. I guess that looks good. I can see it myself as well. Not as good as I want to. Let's try that. Now I can see it, and the camera can't. That's no fun. All right, I guess not. We'll figure it out. All right, well, the first thing I'm going to test is 5 volts. So we clearly have this entire lattice of ground, and we discovered on the close-ups that this right here goes to 5 volts. So, as well as this, and so here I should see 5 volts. And I don't. Yes, I see nothing. I think the reason why is these upper ones are connected to the top connector 5 volts. And we're connected to the bottom connector 5 volts. So let's try that. This one should be 5 volts. There we go. 5.16. Beautiful. All right. That's what it should be. Awesome. Okay. And let's see here. I believe that the outer pins are also 5 volts. Or is it the second pin? The second pin on every board. The first pin is ground, right? The second pin is 5 volts. And I also believe the second to the last pin is 5 volts. And the final pin there is ground. On every board, all 100 pin edge connectors. And that certainly is the way it's looking to be. Yep. Alright, so it looks like the 5 volts is certainly correct. We definitely have 5 volts. Let's see if we have voltage on this one. Yes, we do! But I guess not this one. Nope, because that's fed by the upper power supply, which is not installed. Okay, so what's next? Well, let's check the 15 volts, shall we? All right, so I know, because we have this, we have slots 2 through 12, the inhibit, right? Slots 2 through 12, the inhibit. And so A9, 11, A15, A13, basically there's a whole range in here on slots 2 through 12. So, slot 1, slot 2, slot 3. So I think right in here, we should certainly be getting some 15-volt signals. Let's see, that's going to be 1, 3, 5, 7, 9. That should be 9 right there. So we should be getting 15 volts. And look at that, it's 15 point some change, right? 15.18. One next to it, nothing. So let's see. I'm just going from memory here. 9, 11, 15, 13, 9, 11, 13, 15, 17, 19. Okay. And it should be all on slots 2 through 12. So if I get something on 9, let's see, that's even, that's odd, even, odd, even, odd. We'll test this one, right? So this is, that should be ground, right? That should be 5 volts. And then this is 5. We shouldn't have, well, we got 15 on 5. Good. 15 on 7. 15 on 9. 15 on 11. That's right. And this is going through the 8 ohm resistor on the resistor capacitor board. But, you know, there's no load on this, so I still expect it to be 15 volts. Okay, 15. These whole, all these, I guess, are all the inhibits here. Fifteen, 15, 15, 15, and then nothing. So I think the last 15 is this one, which is 2 before the ground here. That's definitely ground. Okay, so what should that be? What's the highest number we have here? We have some even ones too, right? 24, 28, 25. We have 24 and 28. 25, 27, 29. 29 is the highest odd one here. And so let's make sure that that's 29. Interesting, this grid, I imagine. Let's see, 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, 25, 27, 29! Well, that makes sense. And we should even have some even ones here that have 15 volts as well. But not a lot of them. That one has 15. That one doesn't. That one has 15. That one doesn't. That one has 15. That one doesn't. Well, basically, the 15, the positive 15 circuit is working. I have it connected. It appears that I have it connected properly. Let's make sure though, because those are all a lot of individual lines, and I want to check. So, let's see. We checked all the odd ones. What are the even ones? There's an even one, 24 and 28 and 18. Right? Aren't those the even ones? 18 is an even one. 28 and 24. All the rest are odd. Yep. All the rest are odd. So, we should see 15 volts on 18, 28, and 24. 18, 24, and 28, right? So, let's make sure that we do. Let's see. Odd, even, excuse me, even, odd, even, odd, even, odd. We'll try this one. That's even, right? So we have 2, 4, 6, 8, 10. I got 15 on 10. Should I have 15 on 10? Right? Even, odd. Even, even, even. 2, 4. Yep, definitely should have 5 there. 6. 6 has 15. 8 has 15. 10 has 15, unless I'm on an odd. Yeah, I'm on an odd, right? That's even, odd, even, odd. This one's even. Sorry. 5 volts should be there. Okay. Negative 5 volts. Ooh. That is definitely negative 5 volts right there. That's 15. So that's 2, 4, 6, 8, 10. So 10 has 15. 12. 14. 16. 18. 18 has 15. 20. 22. 24 has 15. 26. And 28 has 15. 30. No. 32. 34 should be ground. Okay. So maybe I just missed 10 over here, because 10 definitely has it. And is 10 listed? 10 is not listed. Huh. Well, no, wait, though. Look at this. Pins 22 and 48 on the P1 go to A10, right? That's plus 15 volts without the resistor. That goes to A10, B46, B84. So I guess we just tested this, right? B46, B84 on slots 2 through 12. So I did just test that by getting 15 volts on A10. Yay! It's working. Okay. Now, let's test the negative 5. Negative 5 unregulated to A6. I think I found that. B81 on slots 2 through 9. A6 and B81. Well, A6 is easier. Okay. So let's see. Even, odd, even, odd, even, odd. 2, 4, 6. 2, 4, 6. So that should be negative 5. That should be negative 5. And it is. Okay. So this is looking really, really good. Looking really, really good. All right. Well, what's left? 12 volts to the lamp ground. Okay. A lamp positive and lamp ground. Well, we should see 12 volts and then the common ground. So where does that go? Let's check it on this pin out here first, because that's going to be easier. I've got to tip this thing over to see that on the other side. Maybe I don't have to. Yeah, I kind of do. All right. That goes to pin 40. Lamp ground. 33 and 40. 33 and 40. That's not right. P1. Now this is not to be confused with any P1 that goes to a power supply. No, no. This P1 is over here. Did you catch that? So this is P2, which goes to the power supply, the lower power supply. That's P1 that goes to the front panel. There's another P1 we found on schematics that connect the resistor board to the lower power supply. Very confusing. But in context, it's obvious what we're talking about, as long as you pay attention to the context. So we're going to now go over here, and we're going to test these for the 12 volts. And hopefully I didn't make a fatefully bad decision. Now, I'm noticing something. I can't really lean this thing over because this comes out of the backside a little bit. So I'm going to try to adjust this. I'm going to tip it up here, but not lean it all the way over. And that's just going to be hard to see. I'll tell you what, I'll do the tests like this, where you'll be able to see one side, but I'll know I have it over here. And we'll take this off so that we can see it a little bit better. There we go. All righty. So what are we looking for? P1, pin 33 and 40. Well, thankfully, I numbered all this out right here. This is the numbering for P1. And it's looking kind of funky the way I have an upper and lower here, but I didn't know how else to represent it. So here's the upper, right? And the lower looks from underneath. So the upper looks from the top. And by the way, you see this picture right here, it only has like 13 pins. Well, that's because this keyway switch is in the way, right? The pins continue to go underneath it. I just couldn't photograph it all in one photograph. And I wanted to be able to see it straight on, but then I had to photograph it at an angle like this to be able to see all of it, but then you couldn't see the markings on the board because the pins are in the way as they raise up off the surface of the board. So there you go. Anyway, I digress. What are we looking for? We're looking for, I believe that both of these are going to be on the back side, right? On this side, underneath, not the top side. We are looking for 33 and 40. And so those are all going to be and I'll tell you what, I'm just going to look for 33. That's all I'm going to look for is 33. Because 40 should be connected to ground. And I think we'll just beep that out. And should be connected to ground through the power supply. So 33. So what do we start with? 27, 28, 29, 30, 31, 32, 33. So we have 27, 28, 29, 30, 31, 32. That should be 33 right there. Well, I guess it helps if I put the probe here on the ground. Nope. Do I have this wrong? 27, 28, 29, 30, 31, 32, 33. There we go. I miscounted. Clearly a nice 12-volt signal there. Okay? And then, that's 12 volts. Kinda. Yep, so I gotta get on it there. It's hard to see this underneath there. So that's 33. And 40 should be ground. It's supposed to be an independent ground, but I tied them together because I'm using the 12-volt regulator from the ATX power supply. So I'm going to put this on beep for connection. Okay. And it's working. So let's see. One of these. There it is. All right, so it's one after the slot, so that should be 40. Yep, and that is exactly correct. As we look at the picture underneath there, we have 39 right there, one before, one to the right of the slot, one after the slot or to the left of the slot, because I guess I'm going this way, right, from right to left, because that's how the numbers are arranged. That's 39, that's 40. So this connector right here, that's connected to ground, and it's connected to ground right through the power supply. And it didn't seem to be, you know, real happy with that connection, but let's test that again. Hear that? Let's just check the ohms there. It's not a real solid connection. Well, we definitely have some resistance there. I got 30 ohms. I mean, it's not a ton, but very interesting. Okay. Well, hopefully it works well. Again, it's just the light bulbs. So I am hoping that, well, we're hoping for good things. Okay. Well, I'm going to consider the backplane tested. And so now the next thing to do is get up enough nerve to plug in a board and power this thing on and figure out what's supposed to happen. No, that's not true. I'm going to plug in the front face first. I want to see what happens when I plug in the front face. And I'm not going to do that this video. That's going to be another video. But we'll at least make sure that we don't burn out any bulbs and see if any bulbs come on. Because I don't know if with no boards, any of the bulbs should come on. I don't know. But anyway, that's it. We have power supply. Let's tip it over one more time and take a look before we end the video. Just because I think it's cool. And there we have it. Floating board. That's it. We have the Data General Nova power supply from scratch. That's it. All right, everyone. Appreciate you watching the test and diagnostic here. If you've watched all the way this far, I appreciate it. Thanks so much for watching. Bye-bye.